Okay, hello everybody. Welcome to today's lesson. We're going to talk about section 12.2, the surface area of prisms and cylinders. All right, now we've talked a little bit earlier in the year about what prisms and cylinders are. We'll talk about prisms first. Remember that prisms have two bases. Every prism has two bases. And prisms are called prisms because they have rectangular sides. So all prisms have two bases, and the sides are rectangles, rectangular sides. So that's what makes a prism, two bases and rectangular sides. Now, to get the surface area of a prism, you just follow the formula. There are a couple of formulas that you may use depending on what type of prism it is and what shape the bases are. But there's also one generic formula you can use for all prisms, and that's the one we're going to use. So that way we only really have to worry about remembering how to use one formula instead of many of them. All right, over here in the rectangle is our generic surface area formula for all prisms. It is surface area SA is equal to 2B plus PH. That's a lowercase h, that's a capital P, and that's a capital B. Okay? Now, here's what everything in this formula stands for. The 2 is obviously a 2. The capital B stands for the area of the base. So that means whatever shape the base is, you have to find the area of that shape separately and then put it into the formula for capital B. If the base is a rectangle or square, find the area of that rectangle or square. If it's a triangle, you got to use the area formula for a triangle and find the area of that triangular base. Okay? Sometimes they might give you the area of the base, and you can consider yourself lucky and put that number straight in for B. Otherwise, you have to calculate this on the side and then substitute it in for capital B. All right, P, capital P, is the perimeter of the base. So again, on the side, you have to calculate the perimeter of that base, which means you add up all the sides. And then H is the height. Now, H is not the height of the base. H is the height of the prism. Now, here's one important thing to keep in mind, because a lot of people, they might accidentally put the height of the base in for the height of the prism, but that is not the case. The height of the prism is not the height of the base. The height of the prism is the height or length that runs from base to base. This is not always up and down. It's not always vertical. Okay, sometimes the height of the prism might be horizontal or diagonal, depending on how the prism is, the orientation of the prism, depending on that, or how the prism is laying or facing or standing, okay? So this is what everything means, and it's a pretty straightforward formula to use. You do have to do some legwork. You have to, on the side, figure this stuff out usually, come back to this formula, plug it all in, and then figure it out and get the surface area. Now, one thing to keep in mind with surface area is that since you're talking about area, it is square units, like square centimeters or square inches, etc. Okay? Even though we're dealing with three-dimensional figures, it's not cubic units. Surface area is the flat area of all the surfaces, so it is square units. Okay? Before we talk briefly about cylinders, one term you might see is lateral area. All right, if you see the term lateral area, what that refers to is the area of all of the sides without the bases, okay? So it's the area without the two bases. Okay, so on a prism, it would just be the rectangular sides. You wouldn't add in the two bases. Okay? Now, the lateral area, if we go back and look at the formula, 2b stands for the two bases. So if you want just the lateral area, if they're talking about just the lateral area, or if they want you to only find the lateral area, all you got to do is take the 2b part off. So in the formula, the pH part will calculate the lateral area. Okay? So if they ever want the lateral area, just calculate the pH part. Don't worry about the 2b because you're taking off the bases. All right? One real thing that's that I put right here, this right here is only for a box, a rectangular prism only. Some people find it easier if you're talking about a rectangular prism or a box to just add up the area of all 6 of your surfaces, because every surface is a rectangle, length times width. So if you find the area of all 6 rectangular surfaces, you can total those up, but only for a box or rectangular prism. Some people find that easier than using this if you have a box. Okay? All right, let's talk real quick about a cylinder. A cylinder, same generic formula, except instead of P for perimeter, remember we don't call it the perimeter of a circle, we call it the circumference. So if you want, you can change the P to a C for circumference, and that would be what you put in for P, would be the circumference of the circle, because that is your perimeter of the circle, the circumference, okay? But it is the same formula, okay? Because you do have two bases, you have the two circles, and then you have the perimeter, which is your circumference, and your height, okay? Now, since you're dealing with bases that are circles, remember the area formula for a circle. To find capital B, the area of the base, the area of the circle, use pi r squared. And for circumference of a circle, remember it's pi d. So you have to use those two formulas on the side to calculate B and C, and then come back in and pop them in, okay? Another term you might see is the term net. Remember, a net is an unfolded three-dimensional figure. If you unfold a cylinder, you have two circles, and you have a rectangle. Lily, you can come out here if you want and get whatever you need. What? You can get whatever you need. I'm just doing my video. You're good. Okay, so if you take off the two bases, those are your two circles. Everything else for a cylinder is the rectangle. That is your lateral area. So the lateral area for a cylinder is your rectangular part, the part that your hand would touch if you're holding a soda can, for instance. And then your two bases are your two circles, your 2B part. All right, so let's see some examples on the back. All right, for the first two, we're going to find the surface area. All right, so number one, we have a rectangular prism or box. So we bring up our generic formula. Surface area, SA, equals 2B plus pH. All right, so here we go. We got to calculate capital B, which is the area of the base. So you can take either base or both the same on a prism. You'll see that the base is a rectangle. So to get capital B, just find the area of that rectangle. It's a 4x2 rectangle. So length times width is 4 times 2, which is 8. And we also got to calculate capital P on the side. That would be the perimeter of the base. So you have a four-sided rectangle. The sides are 4, 2, 4, and 2. So if we add the four sides of that rectangular base up, we're going to come out with 12. So these are the numbers we're putting in for B and P. Now, H is your height of the prism. So the height from base to base would be 9. So we're going to put a 9 in for H. All right, so here we go. Substituting in, we have 2 times B, which is 2 times 8. P times H, which is perimeter 12 times height 9. 2 times 8, 16. 12 times 9, 108. Adding them to get the total surface area is going to give us 124. And if they give you a unit, make sure you attach your unit onto your answer. We're talking about feet. So square feet or feet squared for your unit. So 124 surface area of number 1. All right, so for number 2, here we have a triangular prism. So we're going to pretty much do what we did in number 1, except we just have a different shape. So let's go ahead and write down our generic formula, 2B plus PH. All right, we've got to get capital B. Oop, that should be a plus sign. Sorry about that. All right, so here we go. Now, our base is a triangle. All right, so we got to find the area of this triangle. Same as this triangle, but this gives you everything you need. So, remember, for a triangle, this is your area formula. So you have to calculate this to get capital B. So in this triangle, 1/2 base times height. That's going to be 1/2. The base, which is we see is 10, and the height, not 9, but 8. Remember, the base and height of the triangle are the two that make the right angle, which are 10 and 8. So 1/2, 10 times 8, that's going to give us our capital B value. That's going to be 40. Now for capital P, we know the 3 sides of the triangle. We have 10, this is 9, and this right here, which is the same as this, 8.5. So we add 10, 9, 8.5 to give us a perimeter of 27.5. All right, now we have our B and P values, so we're ready to go back to our surface area formula. So 2 times B, which is 2 times 40, plus P, which is 27.5, times the height, which is not vertical here. It's actually going kind of side to side or diagonal. Base to base, though, triangle to triangle, 20 inches. So 20 is your H value. All right, here we go. 2 times 40 is 80. 27.5 times 20 is going to give us 550. If we add those two, we get a grand total of 630 for our surface area, and our unit is square inches. All right, let's look at number 3. And number 3, we have a cylinder, and it wants us to go ahead and give the lateral area and also the total surface area. So we got to identify and find both of those. All right, so let's look at our formula. It's 2B plus PH, but remember the P is really C for circumference. Now remember, the CH part is your lateral area, okay? And then the whole thing is your surface area. So if we find this part, we'll have the lateral area, and then we'll find the whole formula, everything, that's your surface area. And we'll be good to go. All right, let's look at what we got in the cylinder. Now, base to base, circle to circle is your height. That's 19 here. 16 is all the way across the circle, which is your diameter. So we're going to need R. R would be 8. So your diameter 16 gives you an R radius of 8. All right, so let's go ahead and figure out what we need. We need capital B, which is the area of the circular base. So on the side here, we're going to go ahead and figure out that. Pi r squared. R is 8, radius of 8. So pi times 8 squared is 64 pi. For now, let's just keep it in terms of pi. If we need to approximate it later using 3.14, we can. All right, C for circumference. The circumference is pi times diameter. Diameter is 16. So that would be 16 pi for your circumference or C value. Now, CH is the lateral area. So let's just, now that we have C, let's just go ahead and calculate it and get it out of the way. Well, C times H is going to be C, which is 16 pi, times H, the height, 19. 16 times 19 should give us 304. And we have our pi on there, don't forget. So 304 pi is your lateral area. And if we put a unit, millimeters squared. Okay, so there's our lateral area, which is what they wanted us to identify separately. Now that's our CH. So we can put that in for CH, 304 pi, since we figured that out. Now 2 times B, our B value is 64 pi. So 2 times 64 pi, that will give us 128 pi. So our 2B part is 128 pi. CH lateral area part of the formula, 304 pi. We add those together and keep our pi. And that gives us 432 pi, which is our total surface area. And our unit, again, still millimeters, so millimeters squared. So there we have it for number 3. Total surface area of 432 pi. The lateral area is just your CH part, which is 304 pi. Okay? So that's how you handle a cylinder. Okay, guys, real quick at the bottom, I've given you some hints on number 14 and number 28. On number 14, this is the approximate figure they give you. But in order to get the surface area for number 14, you got to use Pythagorean theorem first to get this side of the triangle. Because they give you 9 and they give you 20 here. So use Pythagorean theorem to solve for this side. And then you'll be able to get capital B and the rest of the surface area. On number 28 on your homework, it wants you to find the surface area of only the part that lies above the ground. So line above the ground means everything except the bottom side, the bottom rectangle. Okay? So what you can do on 28 if you want, you can find all the other 5 sides separately, or if you want, you can just get the entire surface area and then just subtract the area of that bottom rectangle. Either way is fine. So there's a couple of hints on 14 and 28. I did alter the directions a little bit. The book tells you to find the lateral area for some of those problems. You don't have to do that. Just find the total surface area. So make sure you look at what I gave you for that. And the rest of the problems, just follow whatever the book tells you to do. And that's it for today, guys. Thanks for listening and have a good day.